Hello and welcome to today's webinar, organized by Thermo Fisher Scientific. I am Carl Fisher, Product Marketing Manager. Our presentation today is Ion Chromatography, Practical Tips and Techniques for Every User, which will cover tips for column care, extending the lifespan of your IC system, optimizing your IC analyses, and more. Our speaker today is Sean McCormick, Manager, North America Application Support, Applied Markets Lab Team at Thermo Fisher Scientific. Before our presentation begins, we would like to mention a few tips that will enhance your webinar experience. Please submit your questions at any time during the presentation in the Ask a Question widget pinned to your console. We value your time and want to ensure we are delivering high quality and relevant content. Please use the survey to share your comments and suggestions. Explore the menu dock along the bottom of your screen. These buttons open and close all the widgets and windows. Lastly, we are recording today's webinar. The on-demand link will be sent to all attendees via email approximately 24 hours after the broadcast. Thank you again for joining us today. Our presentation will now begin.
Thank you, Carl. Good day, everyone. Thank you for joining me to talk about ion chromatography and some practical tips and techniques for the everyday user. In today's presentation, we will discuss a few different topics, starting with a short introduction to ion chromatography. We'll then move on to talking about ion chromatography system components and their basic maintenance and operation. When we finish that, we'll move on to discussing system vitals and how they can be used to monitor your system's performance. Finally, we'll wrap up with a discussion of some of the additional resources that Thermo Scientific has to offer when it comes to ion chromatography. Why do we use ion chromatography? Ion chromatography is a robust analytical technique that can be used across many different industries, including food production, pharmaceutical, and mining, to name a few. Within these industries, they can support a variety of applications that serve multiple purposes for the business. One of the biggest benefits to ion chromatography is the ability to quantify analytes from the very low level PPT range up to the very high percent. Thermo Scientific offers a variety of different ion chromatography systems to match the performance and price requirements for your organization. Starting at our entry-level Thermo Scientific Dionix and Nuvian Core, all the way up through our Thermo Scientific Dionix ICS 6000 system, we have a solution to meet your analytical needs. Across the board, these solutions provide consistent, accurate results, saving you time and money, along with increasing your throughput, which is beneficial to any organization. Like many other liquid-based chromatography techniques, ion chromatography systems start with a pump. The pump in this case has two possible functions. In some systems, it is the provider of water to be used by the eluent generator for the automatic generation of mobile phase to a desired concentration. In other situations, it is a pump used to provide a pre-made mobile phase to the analytical flow path. In this example, we're using an eluent generator. So the pump will be delivering high purity water to the eluent generator where the automatic generation of a desired mobile phase concentration is carried out using electrolytic processes. Once this eluent is generated, it moves on through the flow path towards the columns. Prior to reaching the columns, it must first flow through the injector. The injector is the access port in the system where a sample can actually be introduced. This can either be introduced from an autosampler or from a manual injection. Once the sample is introduced into the system, it flows through the guard column and then the analytical column. The role of the column is to be the site of the actual separation. This is the stationary phase. In the case of ion chromatography, separation occurs based on ionic characteristics. Charge is an example of one. After the different components of the sample are separated, they are passed on to a suppressor. And in this example, we're using electrolytic suppression. The suppressor's job is to remove the eluent from the flow. The eluent in this case is a salt solution. It's potassium hydroxide in most cases. We must remove the potassium and neutralize the hydroxide in order to minimize our background. It removes the potassium using an electrolytic process which removes the potassium ions and as a result introduces H+. The H+ interacts with, say, an hydroxide and therefore creates water. So what comes out of a suppressor is typically different ions that were separated during your separation on the column and water. It then heads towards a detector. And there's many different detectors that can be used for ion chromatography. In this example, we are using a conductivity detector, and that starts with a conductivity cell, where your sample is passed through, the flow continues right through it, and then we're measuring the conductivity as a function of time. If a peak comes out, either positive or negative, that could be an indication of an analyte being separated on the column. This detector, like any other detector, is connected to our data processing system. And for Thermo Fisher Scientific, it's Chromeleon. Chromeleon is a powerful software that allows for the creation of instrument methods, processing methods, data collection, data analysis, and reporting. As you saw in the previous slide, the ion chromatography system is made up of many different components. In this portion of the talk, we will discuss the key components and how to maintain them and get the best results out of them. Let's start with discussing pumps and, more importantly, eluent. One thing all ion chromatography systems require is good eluent. The eluent can be made manually or prepared using something like automated eluent generation. In both cases, you'll need high-quality water. This is water that should be degassed, deionized, filtered, and 18.2 megohm or better. The same is true with any salts or liquids you use to prepare your eluents. They should be of the best quality available, get the best results. If you use poor quality water or reagents, you may experience elevated backgrounds and it makes your data harder to analyze. Thermo Scientific has developed automated eluent generation to provide a more useful, more reproducible, more consistent experience for our customers. More reproduceable, it utilizes deionized water as the carrier and electrolysis to generate high water as the carrier and electrolysis to generate high. It can online deliver a specific concentration using the Chromeleon software to control the electric current that is utilized in the process. It can also create gradients on the fly without the need for a more costly proportioning pump. Once you have good eluent, you should consider what other tasks need to be performed daily to maintain your pump. There's two of them. The first is rinsing the pump heads. The eluent we use tends to crystallize as water and solvent evaporates. These crystals will form rough spots on the pistons and wear at your pump seals. This will result in leaks within your pump and possible damage to the pistons. In addition to rinsing the pump heads, we should also prime the lines. The eluate lines are susceptible to picking up carbon dioxide and oxygen, which can easily pass across the Teflon. This creates many bubbles, which can cavitate in your pump head. Another benefit of priming your lines is that you remove old mobile phase and allow fresh mobile phase to be used for your analysis. Another area of the pump that needs preventative maintenance is your check valves. People seem to forget about the check valves. What the check valve does is control the directionality of flow of the eluate or mobile phase through your pump so that it doesn't go in the wrong direction. In the case of Thermo Scientific, our check valve assemblies utilize a cartridge design. The inlet and outlet assemblies are different, however the cartridges that are used by these check valves are identical. It is very simple to replace or clean your check valve cartridges. All it involves is unscrewing the check valve from the pump head. Preventative maintenance is key to instrument performance and success. It can be done by Unity Lab Services, a division of Thermo Scientific, or even done by the customer. Preventative maintenance activities use kits. These kits contain all the materials needed to replace pump seals and check valve cartridges, as well as clean and inspect your pistons and replace the priming knob O-ring. If the user follows the scheduled performance, preventative maintenance routine, and the daily maintenance suggestions, their system will operate for many years to come. A key component of the ion chromatography system that not all users take advantage of is the seal wash pump. The seal wash pump provides an automatic flush of the rear seals in your system. This wash minimizes the formation of crystals from your eluate evaporating and allows for better lubrication of your pump pistons. This results in higher system uptime, less wear and tear on your seals, and also contributes to more reproducible results. With the launch of the Inuvian ion chromatography system, we also implemented eluate monitoring. Eluate monitoring lets you monitor the level of solution in the bottle based on its weight. Once the level drops below a set value, the LED light will turn from green to red. This will also be indicated in your e-panels as a color change. When you specify the eluate bottle, the software will use the volume in this vessel to calculate whether there is enough solution for the next sequence to start. If there's not enough eluate, a pop-up window will alert you to this, and it will be logged in the audit trail. You have control over the low-level threshold, light intensity, and when the LED light should go off once the bottle is removed. If we follow along our flow path for our system, the next stop after pumps is injectors, as well as the connections that put everything together. The injection valve is a 6-port, 2-position valve, which its main purpose is to direct flow and introduce samples into the eluate stream. This is typically done pneumatically or through electric activation. The eluate flows in one of two paths depending on the valve position. In the load position, the sample is introduced into the sample loop using either an auto sampler or manual injection. Once it goes through the loop, the excess is sent into the waste stream. When you're ready to put your sample on the column, the valve is turned into the eject position, in which the pump pumps liquid through the sample loop, depositing the sample on top of the column and allowing eluate to fully flow through the column towards the detector. While injection valves look simple, there are sometimes issues that arise while using them. One of them that is seen is irreproducibility of replicate samples. In this case, one possible source of the issue is the sample delivery system. This could be either the auto sampler or the manual loading using a syringe. In that case, you would need to check to see if your sample delivery is actually delivering the sample. Another spot that sometimes causes reproducibility issues is a leaky fitting or a loose fitting on one of those 6 ports on the front of your injection valve. It's very simple to go through, look at the fittings, look for liquid leaks, and to tighten fittings as appropriate. Now, in that case, you don't want to over-tighten fittings, but they should be at the appropriate tightness level. And the last possible cause of reproducibility issues in the valve would be if the valve isn't turning properly. That could be a failure of the valve itself, or that could be that the valve is sticking due to some of the sample types that you're injecting, kind of clogging up the valve. In addition to reproducibility issues, sometimes people see peak shape and carryover issues that could be the result of many things. One of them is that your injection valve seals are beginning to fail. And this could be caused by grooving, degradation, breakdown. This could require a replacement of the valve seal and not the valve itself. Another place that could be investigated is in your tubing and your fittings. It's very much possible that you made a new connection and that the fitting isn't seated properly, the ferrules aren't seated properly, and you're creating volumes where you can cause turbulence and get carryover or weird peak shape anomalies. And another possible cause of peak shape and carryover issues is if you're using a sample loading column or a concentrator column for some more complex applications. If they're starting to go bad or are contaminated, they could cause abnormalities in peak shape and carryover as well. One aspect of my job is to interface with our tech support team. While doing so, we've determined that the most common problems that our customers face are typically related to bad water or eluent and bad liquid line connections. We've already discussed the need for high quality water and taking care in the preparation of your eluents, but let's spend a moment talking about tubes, fittings, and ferrules. One of the things I'd like to start out with is always using an appropriate peak tubing cutter. This is not the time or place to use a pair of scissors or try cutting with your pocket knife. This could distort the end of the tubing and not allow a good connection. The second tip is you have to remember that finger tight is tight enough. If you over tighten a fitting that's made of plastic, it will distort the end and not allow it to seat properly. And last but not least, the liquid seal is made by the end of the tubing, not the ferrule itself. So a good clean cut on the end that's flat will sit better in the fitting and therefore make a cleaner connection. If we follow these tips, we should avoid a lot of the bad liquid line connection phenomenons that people observe in their data. That's things like leaks, high back pressure, abnormal peak shapes, poor reproducibility, additional baseline noise. These should all be avoidable. Now, if they're continuously a problem for you, I would recommend that you explore adding the Viper tubing solution to your system. And we'll talk about the Viper tubing solution in a minute. The Viper tubing solution really simplifies your plumbing for your system, and this is unique to COrso Scientific. In our case, for ion chromatography, we are using peak tubing for this. And what it includes is a piece of tubing set to a specific length with the ferrules and fittings already fused on the ends of the tubing. These can be sold for new hardware systems as well as existing, and they can come as kits for your specific instrument. Since we've already talked about pumps and your injector, let's talk about the next step in the flow path, and that's the columns. When it comes to columns, I have the following tips about their care and cleanup. My first tip when it comes to columns is always use a guard column. This will retain any contaminant that's present in your sample and protect the analytical column. My next tip is when you're not sure about what an appropriate cleaning solution is, just start with a 10x or 100x of the eluate concentration you use in your analytical method. When doing this cleanup, you want to start by placing the guard column after the analytical column. This will keep the contaminants from getting pushed further onto your analytical column. Also, when we're doing a cleanup, we typically run at lower flow rates. If you're doing 2 millimeter columns, you're flowing at about 0.2 mils a minute. And if you're doing 4 millimeter columns, you'd be at about 0.5 mils a minute. This allows for deeper cleaning of the column. And last but not least, when doing a column cleanup, always pump your cleaning solution through the columns in the same direction as the analytical flow. There's a lot of people out there that'll say turn it in reverse and reverse the flow through your column. This is not a recommended practice. Now, that 10x to 100x eluent might not be useful. You might have organic contaminants or transition metals. And in these cases, you would have to use solvents or a chelator. If you're doing this, you want to wash them in between with the ionized water. Now, if you're ever interested in learning about cleaning your column, this information is available in the column manual. This has more information about operating, the maintenance, and troubleshooting, as well as the very vital cleanup information. This is available with your column and online. If you have issues you believe are coming from your column, I would take the following steps to try and troubleshoot the problem. The first thing I would do is remake my eluent. If you have an automated eluent generation system, that would involve placing a new water bottle on your system. If you manually prepare your eluent, that means preparing a new batch of eluent from scratch. The next thing I would do is check my system for leaks. It is very common that we go through a system and we find that one of the fittings is leaking, and therefore you may not be seeing your peaks in the detector and may be leaking out before the detector. Another area you can look at is checking if your pump is running properly. Easiest way to do this is to take a small graduated cylinder and with your pump flowing at a set rate, measure how much is delivered for a given period of time. Then check if those two numbers are in agreement. If they aren't, there's probably something wrong with your system. And then last but not least, I would clean or replace my column. It doesn't hurt anyone to clean a column, it's just time, and it could save you a lot of money and effort in the end by just running a cleaning on your column. Again, all those instructions are available to you in your column manual. Those are available online for everyone. Many users think that the column is the most important part of their ion chromatography system. I beg to differ. I believe the most important part of your IC system is your suppressor. The suppressor allows for removal of a substantial amount of your background, allowing for easier detection of low-level analytes in complex matrices. In this section, we will discuss suppressors, and I will give you some tips on how to get their best performance. When it comes to suppressors, there are many different types. For the sake of simplicity in today's talk, we're going to discuss the dynamically regenerated suppressors, or the DRS, which are part of the electrolytic suppressor family. The DRS suppressors have many benefits to the end user, including fast startup time, low background noise, and the ability to handle higher back pressures. On the right-hand side of the screen, we are showing you a view of what is happening within the suppressor. In this case, the eluent, sodium hydroxide, is passing in the inner chamber. On the two chambers on the outside, we have regeneration water flowing through. At the anode, the water is being split to release oxygen and hydronium ion. The hydronium ion enters through the membrane into the flow path where it interacts with the hydroxide, creating water. In order to maintain charge balance, the sodium transitions across the membrane into the waste stream towards the cathode. This leaves us with water and our analytes flowing towards the detector. Much like the column manuals, the suppressor manuals provide vital information about how to operate and maintain your suppressor. The most important maintenance task when it comes to your suppressor is proper hydration. Hydration is necessary when the suppressor is new out of the box or has been in prolonged storage. Hydration is the slow addition of water or eluent to the membrane surface, allowing them to plump up and separate. We want to do this slowly and gently, as if you try and do it too fast or with too much force, it could rupture the membranes of the suppressor and therefore dictate its replacement. The instructions for doing this are available in the installation checklist and in the suppressor manual. There is also a great resource in an on-demand webinar entitled Suppression Unraveled: Cost Savings, Sensitivity, and Robustness. The biggest tip I have for the hydration activity is to make sure that your waste is not plumbed into the flow path of your system. You do not want to flow the liquid that comes out of a suppressor during hydration directly into your conductivity cell or any other detector. Sometimes during the initial hydration of a suppressor, some of the fines of the resin within the suppressor or small particles will come out and could possibly clog your detector. Leaving your detector out of this allows for those to go to the waste, and we won't have any clogs. One of the most important parts of maintaining your system is installing your consumables correctly. Some individuals can read a user manual and understand exactly how to do the task and do it correctly. Others are visual learners. Great thing about thermoscientific ion chromatography systems is that there are videos in Chameleon demonstrating how to do the different installations of consumables such as columns, suppressors, or other devices that are required to keep your system running in tip-top shape. The DRS suppressors, like many other thermoscientific suppressors, are electrolytic devices which are programmed in your instrument method to perform under certain electrolytic conditions. In the case of the DRS suppressors, there are two operational modes. There's legacy mode, which refers to a constant current approach, or dynamic mode, which is a constant voltage approach. My recommendation is to always use the legacy mode, which is constant current. You'll also want to remember to use the correct amount of current for your flow rate and eluent concentration. The great thing about our chromatography systems is that Chameleon can calculate the correct amount of current needed for you. In the instrument method, you enter the amount of eluent or the concentration and your flow rate. It will then calculate the current for your given suppressor. Now, it's important to remember if you're running a gradient, you should enter the concentration at the highest point in the gradient. We want to make sure that we have the capacity to suppress all the eluent at the highest point in your gradient. So we want to set it to that highest value during the calculation phase. Now, you may be asking yourself, if that amount of current is good, why don't I just turn it up a bit and add a little extra? While that's an interesting thought, it's not good for your suppressor. It provides greater wear and tear on the suppressor, can cause the suppressor to overheat, and as a result, be less efficient or even destroy it in the long run. When it comes to suppressors, we typically hear about three different issues that arise during their usage. One is leaks, two is high background conductivity, or three, spikes or increased noise in the data. It's hard to tell whether your suppressor is functioning properly by just looking at it. If I'm looking at my suppressor, it's normal to see air bubbles forming in the regenerate out tubing. This is due to the hydrolysis process and the formation of oxygen and even some hydrogen. If I'm looking at my suppressor and I see liquid coming out from around the sides of the ports, This is one of the most common issues we hear about. That's a leaky suppressor, and we need to figure out why it's leaking. First reason it could be leaking is really simple. We just didn't tighten our fittings fully. Go and check the tightness of your fittings. The second reason we could be seeing a leaky suppressor is that we didn't hydrate the suppressor properly, or we've applied too much current to our suppressor. This causes the membrane to fatigue and start to leak. We can possibly recover from this by rehydrating the suppressor and taking it slow with bringing the system back online. The third reason a suppressor may leak is that we've provided too much back pressure on the membrane. This causes the membrane to rupture, and this is irreversible. We will need to change it. When it comes to suppressors, there are three main issues that typically arise. The first we've already discussed, and that's the leaky suppressor. But what about the other two? The second most common issue with suppressors is a consistent elevated background signal that has occurred over time. This could be caused by a lot of different reasons, some of which are due to the suppressor, some are not. If we're looking specifically at the suppressor, this could be caused by something simple, such as the suppressor is not turned on, or it's set incorrectly in terms of current in the instrument method. A third option is that it could be contaminated from running dirty samples. When looking at the suppressor, it's probably best to start with the computer side, the software side. Is the suppressor turned on in the software? Is the current set correctly? Does it look right? And finally, we can try and determine if it's contaminated. This is hard. In order to determine if a suppressor is contaminated, typically you would wash the system and see if, when observing the background, if it was still elevated. If it's still elevated, the next logical step would be to swap it with a new suppressor. Now, your suppressor sometimes doesn't fail all at one time, or you don't observe changes happening all at one time. You may notice the third most common issue that arises with suppressors, and that is you will start to see spiking in your data. As seen in the screen here, this is something that could be indicated by contamination, could be running the current wrong, or not following a standard sample prep procedure. Now, we're not as far gone in this case as the elevated background, so we could try hydration and avoid trying to quick start the system, or we could try cleaning it and see if those eliminate the spikes. There's also a third option, and that's that this is air. Air bubbles have entered the system. If you see the spiky behavior in your data, it could be trapped air. And that trapped air could be in many different places within your system. The two most common places to find trapped air are in the suppressor or in the detector cell. Now it's simple to get rid of that trapped air. To do this, we burp those two devices. To burp the device, we loosen the fittings and we tap on the cell or the suppressor gently. If it is trapped air, after a little bit of tapping, you will see the cell burp and the bubble and spiky nature of your data will resolve. Maintaining your ion chromatography system is not hard, but does require dedication. Even the best kept systems will experience an issue at one time or another. Here I'm going to provide you with 4 steps for troubleshooting your system when issues arise. This will hopefully maximize your system uptime and allow you to resolve your issues in a more strategic fashion. The first step in troubleshooting your system is to identify the symptom. In order to identify symptoms, you need to know what normal is for your system, and that's what I refer to as system vitals. If you know your system vitals, you will know when something doesn't look right. Another way of identifying symptoms is through the appearance of leaks or alarms. If you see a leak, that is an issue. If you see an alarm, that is also an issue. You can look at the status of alarms in your audit trail in Chameleon. The next step in troubleshooting your system is to identify the consequences. What is happening based on the symptom? For example, if you have a high back pressure, what is the consequence of a high back pressure? The back pressure on your system could affect the ability for eluent to flow and therefore affect your retention times. A bad retention time could therefore cause the processing method to not detect the peak properly and quantitate it. The next step in troubleshooting your IC system is to isolate the cause of the problem. And this is where people usually get hung up. They try to start with the most complex things. Really, what you should be doing is starting with the basics. It is not a bad idea to check your eluent first. Is your eluent new? Is it correct? Has it been degassed? Those are all very simple things you can start with that don't require a large investment of time or money. The next thing that people and end users don't do is they don't change only one variable at a time. They try to change multiple variables. This isn't good. We need to change one variable at a time and be very methodical. We need to record the changes to the system and the results of those changes. A good example of this is for back pressure. If my system back pressure is high, one of the things I will do to isolate the cause of the problem is to remove the detector. If you remove the detector and your back pressure stays the same, there is most likely a clog prior to the detector, and the detector is perfectly okay. But you have to do it methodically. You don't want to change multiple variables at one time. If you follow those first three steps, you'll get to the phase of repairing the problem because you'll have identified it. If you identify the problem as something that you can handle, go ahead and change the column, change the mobile phase, do any change that you feel comfortable doing. But understand there are sometimes issues that require expert level assistance. These experts have the correct methodology for making the repair and also the source of certified parts which will support your system. In the previous sections, we talked about maintaining and troubleshooting your ion chromatography system. But how do you know when things are going wrong? The answer is quite simple. You need to understand your system vitals. The system vitals will be your indicator of your overall system performance. We can look at instrument performance by three main vitals: the back pressure, background, and baseline noise of your system. The column performance can be dictated by retention time, peak shape, and resolution. Let's start by discussing the instrument performance vitals. These are vitals that we baseline prior to experiencing any issues. If we look at back pressure, which is always available in your instrument control panel, we're talking about the pressure within the system caused primarily by the column sets, but also is contributed to by the tubing and other aspects of your flow path. If I didn't have a column in my system, I'd expect a back pressure of somewhere between 50 and 100 psi. Once I put a column in there, the number would be significantly more. What I want to do is figure out what my number is when I have a new column in my system. The next vital is background, and the background is the detector signal from your instrument when a blank solution is measured. It is the signal from just your eluent. This number can be plotted or can be observed by looking at your total conductivity reading. And last, when it comes to instrument performance vitals, is your baseline noise. And the baseline noise is unwanted fluctuations or disturbances observed on the baseline of the detector signal. So this is the ripples in your baseline. This is not something that is just put out there in terms of a reading right on the screen. It is something that you can actually plot and can be graphed to provide you with additional feedback. We'll talk about that in future slides. Understanding your vitals and how they are changing as a function of time is important for your daily understanding of your system and diagnosing issues when they arise. In Chameleon, there's the trending function, which allows you to take a vital such as system pressure and look at it as a function of injection, date, or time. In the data below, we're seeing a trend for system pressure, which shows a sudden decrease in pressure and then an increase. This can be used to investigate the cause of the issue. Now that we know the system vitals we should be tracking to look at our instrument performance, you're probably asking yourself, well, what do I do with that information? Well, we use that as a tool to help us troubleshoot when regularities start. If we're looking at something affecting back pressure, if you have a low back pressure, some of the possible causes could be a trapped bubble. It could be just noise. It could be unstable flow rates. With high back pressure, you could have a leak. You could have damaged components. You could have noise. If it's a high background or a low background, these are some of the common things to look at. And if you have a noisy baseline, these are some other areas to look into. So this gives you hints of how to progress in your troubleshooting. While instrument performance is important, it often goes unnoticed. Most users will pick up on column issues more than instrument issues due to their visual nature. But column performance vitals people should look at are retention time, which is the time it takes for a specific analyte to travel through a column from point of injection to the detector, the peak shape, the visual appearance of a peak on a chromatogram. In ion chromatography, the ideal peak shape is Gaussian, meaning that you're symmetrical and have a bell shape. And last but not least, the resolution. The resolution is the degree of separation between two peaks in a chromatogram. It quantifies how well two peaks are distinguished from one another, indicating the effectiveness of a chromatographic separation. A higher resolution value signifies a better separation of the two peaks. Much like the instrument performance vitals, the column performance vitals can be trended in Chameleon. This is an example of the retention time trend. So what we do is select a specific analyte and it is trended based on the injection time or date, as we see below. In the most recent data in that graph, we're seeing an inward shift or an earlier retention time, which could point to a potential issue. Much like instrument performance vitals, the column performance vitals can point you down the path to begin your troubleshooting. In the table below, you can see the 3 column performance vitals and some of the causes that should be investigated when troubleshooting. So if there's a retention time shift, we can look at everything from contamination to a gradient problem. Now that you know what vitals to track for both your instrument performance and column performance, you need to dictate a process in your lab. There are many labs that do the manual approach to this problem and utilize either a clipboard or binder next to the system with pre-printed tables. The user is then required to fill it out either daily or with each batch as they are running, and then to manually graph the outcomes to determine trends. A second option is to do it with Chameleon using a system suitability test and trending the outcomes. This is an easy practice to establish in your labs and allows for data to be accessible not only to the user, but also the management and QA/QC departments when needed. It takes away all the manual plotting and gives clean visuals of the performance. When it comes to shutting down your system, we treat it as either a short-term shutdown or a long-term shutdown. A short-term shutdown is anything longer than 3 days, but less than 10 days. A A short-term shutdown typically involves refilling our water or eluent, then stopping the flow and powering down our components. When we're ready to restart the system, we will prime the lines, then do a wash step of whatever is dictated in our procedure. We will then equilibrate the instrument at the starting conditions for that application till we see a stable baseline. In situations that are less than 3 days, and when we're running 2mm columns in our lab, we leave the flow on overnight at the starting conditions so that the system is ready to go in the morning. This is really minimal amount of waste at 0.3 mils a minute, and we feel that it doesn't affect our eluent usage. One of the questions we get asked the most on the applications and training team is, how do I shut down my system appropriately when I'm not going to use it for a while or I'm going to be away? In this case, we're defining that as any more than 2 weeks. This is a multi-step process that, when completed correctly, will save you a lot of time and headaches in the future. The first step in this process is to prepare the column for storage. And to prepare the column for storage, we're going to look at the instructions in the column manual. It'll dictate what the storage solution is, how to cap the column, and how to store the column once its ends are plugged. Next, we're going to actually remove the column from the system and plug the ends to keep it from drying out. As we move along, we're going to then remove the eluent generator cartridge, plugging both ports on it and putting it away for storage as well. After that, we are going to take the CRTC, hydrate it, and plug the ports, and do the same thing with the suppressor, hydrating and plugging the ports to avoiding a dry out situation. Once we've done all that, we can take a piece of tubing, connect it to where the column inlet would go and where the column outlet lines would go, and we'll flush the system with deionized water for at least 30 minutes to really flush out any eluent and minimize the chance of crystallization. Once we've flushed it really well, we can turn off the power to all the components and then turn the whole system power off. And it'll be ready to go when you're ready to use the system again. As with all analytical instruments, the daily use of a system will cause wear and tear, and inevitably something will go wrong with the instrument. With the launch of the Inuvian ion chromatography system, we also introduced a 5-year optional service, which is called Ion Care. Ion Care is complete coverage, including both parts, labor, and travel, as well as preventative maintenance. For additional information about Ion Care, please check out thermofisher.com/servicescentral. As a leader in science, Thermo Scientific is here to help you meet your analytical needs. We provide application support through application notes, which provide you with all the details needed to reproduce the experiments. Technical notes that give you deeper insight into the most challenging applications, and through on-site and remote support with members of our application team. Another great offering from Thermo Scientific is AppsLab, an online library of application documentation, which is fully searchable and free of charge to our customers. In addition, it's more than just IC. It covers a broad range of analytical techniques. In addition to application information, Thermo Scientific has additional resources including instrument instruction manuals, consumable manuals, as well as a dedicated website for ion chromatography, thermofisher.com/IC. I know we covered a lot of information in today's talk, so I wanted to end it with a summary of some of the top takeaways I hope you've got from the presentation. One of the top takeaways is that a well-maintained system will provide you with more uptime, superior data, and less headaches. And in order to do this, you need to know your system performance or your system vitals. If you know this information, it'll help you diagnose and troubleshoot. Another important takeaway is that preventative maintenance and staying on schedule is important. And when in doubt, you can consult the manual. The manual has a vast amount of information on not only the operation, but also the maintenance, how to do it, and the schedule for doing so. Something else that I hope you take away from this is when troubleshooting, only change one variable at a time and be methodical. Take notes on what is done, the results, and sample data if possible. The biggest thing of today's talk, and I hope I demonstrated, is that Thermo Scientific has a variety of resources to support you, not just people, whether it's my group, the service team, or product management team. But we also have a lot of materials which are easily accessible to the end user. With that, I'd like to thank everyone for attending today and being such a wonderful audience. I would also like to remind you that Thermo Fisher Scientific is here to help you with your analytical needs for even the most challenging, complex scientific applications. I believe we have some time remaining, so I'll turn it over to Carl to start the question and answer section.
Please submit your questions via the Ask a Question widget pinned to your console, and they will be answered as time allows. If your question has not been answered during the webinar, a member of our team will follow up with you by email. A few reminders before we end today's webinar. Please provide your feedback in the short survey widget on your console. Resources are available to download in the related content widget. Lastly, a recording of this webinar will be sent directly to you via email within 24 hours for your convenience. Thank you once again for your time and attention today. Okay, so let's jump into the questions here. Can you explain the importance of sample preparation in ion chromatography?
Yeah, so sample preparation is really important to ion chromatography because it does two main things for you. It keeps your system cleaner and performing at its top condition, and also it helps you get better results. Something as simple as filtering a sample removes the particles that could clog your column and require you to change your column sooner. And even doing something like passing it through an on-guard cartridge to remove transition metals gives you better results in terms of they're more reproducible. You have a lower background, and at the same time, it prolongs the life of your items like your suppressor.
Okay. Great information there. Let's see. How can Chromeleon CDS be used with my IC for better automation and reporting?
Now, the ion chromatography systems and the way they interface with Chromeleon is really nice because it allows you to fully control the user experience from the creation of your sequence or your batch to being able to program it to run different methods within a batch, assign different levels of calibration, going all the way through the processing method, which once you've created it, allows it to always be there and usable for your end user. And then the interactive nature of the data processing and the reporting functions is you can really customize your experience to be able to do the tasks you need. And once you've created all these individual components, what's really nice is that you can create an e-workflow. And an e-workflow really simplifies it for the end user. If you're running the same experiment day in, day out, reporting the same types of numbers, what e-workflows do is allows you a one-click solution to go and take everything you've done during method development and process validation and to apply it to in your everyday work without requiring the user to go through tons of different steps. So it's really nice that you can go through and automate everything from your bottled eluent checking of how much eluent is available to having the reports ready when you walk in the morning if it's ran a batch all night.
And remind me again, where can you find those e-workflows?
Those e-workflows can be found, if you're creating yourself, can be found on your Chameleon home screen. Or if you're looking for e-workflows that have already been produced or coming from an app note that you found in our Apps Lab, you can go through e-workflows right there in Apps Lab. And for everyone, the Apps Lab is a really powerful tool that not just gives you experimental information, but it actually provides the real files needed to actually run those applications as well.
That's great. Let's see, what else do we have here? What are the benefits of using the Thermal Scientific Dionix high-pressure IC systems?
So the benefits of a high-pressure ion chromatography system in general is that with higher pressures allowable on your pump, you can move to smaller, one of the big benefits is you can move to smaller particle sizes. And we make some really nice columns that utilize smaller particle size, which allows you better separation of your analytes, allowing you to reach lower detection limits. And along with that, it also allows you to run faster in some instances. So if time is important to your analyses, you can put a higher throughput of samples per day for certain applications. And we are really the pioneers in this at Thermo Scientific, in that we have our peak body pumps. All of our pumps are made out of peak material, so we don't see interferences coming from the substrates that the pumps are made out of. So it's a really nice high pressure option.
Okay, we have quite a few great questions here. Let's see. What are the key factors to consider when selecting columns for ion chromatography?
So when it comes to selecting a column, I always start with, what are you trying to analyze? It's a very straightforward question. Are you looking at anions? Are you looking at cations? Are you looking at carbohydrates? And that is kind of the first identifier you need to know. The next is, what type of matrices are you running? Are these really simple matrices where there's only one or two components in them? Or are they very complex matrices where you need really good separation to be able to detect specifically what you're looking for? And then third is, what else is in those matrices? There are some situations where some columns for anions may work better than others because you may have a ton of chloride in your sample and you're actually looking for everything else. So really going through and thinking about what your analytes you're interested are, what your matrices is, and also what amount you're expecting in your sample, or what kind of range of amount you're expecting in your sample, all can point you in the right direction to selecting the right column. And when you're selecting a column, there's always the selection guide that Dionix has, and it's available on the IC Learning Hub. And also we have Apps Lab. That's another place to identify which column to use. And last but not least, we have Virtual Column, which is available to our users to go through and see approximately when different analytes would come out on different columns and kind of virtually try out different separations. So that's kind of how I approach selecting my column for my procedures or my applications. Okay,
we only have a few minutes left here, but I think could squeeze maybe at least one more. Is element monitoring available only with the Dionix Innovian IC system?
No, actually, it's available on all of our current IC system portfolio. So it's everything from the Innovian to the Integrian to the 6000. It involves purchasing the element monitor, uncoiling the USB cable, and just activating one of the drivers. So there is a little bit of steps. It's about 3 steps, to be honest with you, and we can provide all the information on how to get it successfully working on your system.
Okay, so 2 minutes. Maybe we'll tackle one more. How can IC be integrated with other analytical techniques for comprehensive analysis?
The great thing about IC is that it really can handle a lot of different backends and can supplement other types of information being collected in your lab. So you can connect an IC system to a mass spectrometer, a good old triple quad, single quad, Orbitrap for doing complex work where you can get lower limit quantitation, more selectivity, and actually get more chemical information about your samples and about the analytes that are eluting off your column. Another would be something like ICP-MS. You can get, again, speciation analysis, better quantitation, more diverse analyte detection, and really more information. There's lots of different detectors you can plug into an IC, and other techniques you can hyphenate in, things simple like UV. We use electrochemistry and conductivity all the time, and you can go even further. We're seeing work in FTIR. There's lots of people connecting ICs to different backends to be able to get a more complete view of their samples and learn a lot more and dig deeper into them.
Okay, great. Unfortunately, that's all the time we have for our questions. Any questions that weren't answered, we will follow up via email. I'd like to thank you once again for attending and have a great day.